Hey guys, Mrs. Sands here. So I'm going to keep this video as short as could be. You already watched a video last night about reminding you how to graph quadratic equations, which makes that U-like shape that we call a parabola. We know that we could just enter it into the graphing calculator, record some points, and plot them. And one important key feature is definitely the turning point. So sometimes we can't see the turning point on our graphing calculator because it's not on integer values. So I do want to do one problem with you, showing you what we can do. So you already took these notes. You know how to graph a parabola in this fashion. Let's just do the do now since we didn't do that yet. So we can solve this by factoring. This is one of those easier trinomials because the coefficient of the x squared term is 1. So things that multiply to be a negative 5, that add to be a negative 4, could be negative 5 and positive 1. Remember, we set each factor equal to 0. You have to make sure you use correct mathematical terminology when you're describing this. Some of you skip this step that I'm writing right now. It's actually a very important step. I would wish that you would write this down showing that you're setting each factor equal to 0. Now the next step where we add 5 to both sides, that part you can skip and you can just go right to saying that x is 5. And when we subtract 1 from both sides, we get x is negative 1. So our solutions, which we could also call our zeros, are at 5, negative 1. And from watching the video yesterday, you saw that where it crosses the x-axis, those are called the solutions, or they're called the roots, or they're called the zeros. And notice where the parabola crosses the x-axis is at negative 1 and 5, the same exact answers that we get from factoring. So that's how come we're calling this lesson Solving Quadratic Equations by Graphing. Where the parabola crosses the x-axis is actually the solutions or the roots or the zeros to that quadratic equation. So which is more efficient, which uses less time? I would say factoring is way quicker than graphing, but you can verify your answer that you factored correctly by graphing it. But like I said, we have to talk about where maybe we don't see this turning point in our table of values. So on this next page, it talks about that sometimes we can't see the turning point. So we have to use this formula that finds the axis of symmetry. We learned that the axis of symmetry always goes through the vertex. So if you can find the axis of symmetry, we actually found the x-coordinate of the vertex. So let's pretend that we couldn't see the turning point in this table yesterday. Let's use that formula that says x equals negative b over 2a to find the axis of symmetry, which will be at x equals 2. So remember, all quadratic equations should be written in standard form, which is ax squared plus bx plus c, right? And right now, since we're graphing it, it equals y, and we just need to know our a, b, and c from our do now. So the do now was at y equals x squared minus 4x minus 5. I'm just going to write that down here. Y equals x squared minus 4x minus 5. So our a is 1, our b is negative 4, and our c is negative 5. So if we use this formula and substitute in the values, x equals negative 4 over 2 times 1, which means x equals positive 4 over 2, right? Negative times negative is positive, which simplifies to x equals 2, which we already knew, right? We knew that the x value was 2. We knew that the axis of symmetry was the equation x equals 2. So this formula definitely works. It finds the x value of our vertex. So to find the y value, we substitute that x value into the equation, right? So here it's asking us to now find the vertex by substituting in our x value. So remember the equation was y equals x squared minus 4x minus 5. But I know that my x is 2. So let's find out what the y is by substituting in that 2. 2 squared is 4. 4 times 2 is 8. 4 minus 8 is negative 4. Negative 4 minus 5 is negative 9. So now I just found out that the y value is negative 9, which means my vertex must be at 2 comma negative 9. If we go back to the do now, it is at 2 negative 9. So the formula works, which means now we can apply it to problems where we can't see the vertex on our graphing calculator. I would only use that formula if I can't see the vertex on my graphing calculator. So we're going to move to number 3 on page 33. Because I know this one, if we did it on our calculator, we're not going to see our vertex. So let's pull out those calculators and actually see what we do see. So if we go to our y equals and enter 2x squared minus 3x plus 5 and look at our table, if we scroll through, we're never actually going to see the turning point. I could see where it's turning. It's like someplace in here. Do you see, like, I have a high value of 19, and it's decreasing to 10, decreasing to 5, decreasing to 4, but now it's increasing to 7. So someplace right in here is where it's turning. But I don't see that nice symmetry in my table of values. I'm actually going to write down this information. So this is the information I get from my table. Let's just plot those points on our graph. So I haven't connected this with a smooth curve yet, and that's because I have to find the exact turning point. It is down here somewhere. It is not the 1, 4 though. It's somewhere in this area because I know it's turning around, but it's not exactly 1, 4 because I don't see that symmetry in these points. I do see this U-like shape, but let's find that turning point using x equals negative b over 2a. Remember, this is the formula for the axis of symmetry. And then after I find this x value, I'll substitute it in to find the y value. There's one thing I just want to point out. Remember, we always, when we're solving, when we want this equal to y, we want this equal to 0, and when we're graphing, that 0 is our y value, like when I put it into my graphing calculator. So a in this case is 2, b is negative 3, and c is 5. So if I use x equals negative b over 2a, I get x equals negative 3 over 2 times 2, which means x equals positive 3 over 4. So I just found the axis of symmetry. It's at x equals 3/4, which is the same thing as 0.75. So the x value of my turning point is 3/4, or if you like 0.75. Now I'm going to substitute this value into the equation to find the y value. So y equals 2 times 3/4, which is 0.75, if you like that better, squared, minus 3 times 0.75 plus 5. We could put this right into our calculator. I'm going to go to the home screen and type in 2 parentheses 0.75 squared type it in exactly as I see it. It would be good if I did it exactly as I saw it. 0.75, Mrs. Ann's. Okay. It tells me the y value is 3.875. I just want to remind you about something on your graphing calculator. If you entered it in as a fraction, you'd probably get a fraction answer here. Remember, in the math key, we could go back and forth between fraction and decimal. If I wanted to turn my decimal into a fraction, I use number 1 here and hit enter, and there is my fraction. And I can change it right back to a decimal, number 2. So anyway, I know where my turning point is. Let's plot it. So of course it's an estimation, but now I could see where it's really turning around, right? It's actually before that 0.14. So it's decreasing until it gets to 0.75, comma 3.875. That's where it turns, and then it starts increasing. So you cannot graph this properly until you find that turning point. So that is a very important key feature. So that's really what I wanted to show you. In class, I want you to finish up these class problems. Again, use your calculator first. If you can see the turning point, you don't need to use this formula for the axis of symmetry. It's only when you don't see the turning point in your table of values that you should then use x equals negative b over 2a to find where the axis of symmetry is, which is the x value of the vertex. After you find the x value of the vertex, you substitute it into the given equation to find the y value, and now you know the turning point. So I'll see you soon. Finish up the classwork, and then you can start the homework. See ya. Bye.